Good morning, everyone, and welcome to the tutorial session about WiMAX and instrumentation of experiments with WiMAX and GIMI tools. So today, I'm Nick, by the way, and together with Ivan and Manu, here and here, we will present a set of tutorials on three subjects. And the difference of this tutorial with other tutorials is that we try to prepare a set of tutorials that are not basically toy experiments. There are things that can show the potentials of GENI and WiMAX testbeds. And you can go to this link. This is the link of the tutorial page. And if you scroll down, you will see three subjects. The first subject is DASH, which stands for Dynamic Adaptive Streaming over HTTP. It's a standard that has been embraced by 3GPP and major players like Apple, Microsoft, Qualcomm, and Netflix. And yes, thank you.
No problem.
There it is. And here we're going to see and evaluate different rate adaptation policies. What Dash does is it adapts the streaming according to the buffer state, and which is by itself affected by the channel state. The second one is stream loading, where it has to do with layered video. This is an idea of Professor Shivendra Panwar at NYU-Poly. He wanted to combine the benefits of streaming and downloading. So in this case, you have then the video is layered into a base layer and several enhancement layers. And you can download the enhancement layer ahead of time and stream the base layer. And the third part is the cooperative packet recovery, which is a tutorial that we presented, I think, several times. And it has to do with the recovery of packet between, let me explain the scenario. Let's say that you are in a stadium and you cannot hear, sorry. Let's say that we are in a stadium and there's a base station streaming the game. And there are users that have better channel conditions and there are users that have worse channel conditions. So if you lose a packet and you're one of those who have bad channel conditions, instead of asking from the base station to stream again this packet, you could form an ad hoc network with your peers and ask them to provide you the packets. So this is the outline. You can choose whatever you want. I'm gonna do the cooperative packet recovery one. Stream load will be in the hands of Ivan, and Manu will do the rate adaptation one. So I'm going to be sitting, OK, Ivan is here, Manu is here, I'm going to sit somewhere there. According to what you want to do, which one you're going to choose, you have to gather around the tutor.
Please don't everybody choose the same thing. We need to split.
Yes. So
We can
okay.
That's fine. So you want them to do and we just help them drive it, or should I drive it first? And then
We drive it first, yeah. We drive it first. So I guess you've already decided.
I think you want to do this like.
Okay. So I'm going to unplug this now and interested in Dash? You can come over here.
It's not for us, so if we are not familiar with.
It will not be really difficult.
No, it's not just.
You guys can sit with him. Believe me. No problem. Yeah, because if everybody goes there, we're in trouble.
Yeah.
Okay. Individual tutorial.
Yeah. You know that. Don't worry. It's not that important.
Always very scared when they don't know where it's from.
Again, dash over here, stream loading to Ivan, and cooperative packet recovery here. If anybody's interested. Yeah. Yeah. So again, we need to split into 3 groups. And yeah, the first group is stream loading with Ivan, second dash with Manu, and the third one packet recovery with me. Yeah. Packet recovery? Why not? Yeah, you need to be closer to me. Stream loading.
But guys, it doesn't really matter where are you going to end up with. You'll learn the needed things. So.
Okay. And you need putty?
Not a problem.
Oh, yes. Packet recovery, background scenario idea. Anyway, so this is the experiment configuration. We have several nodes. Has anybody of you participated in a WiMAX tutorial before? No. So yeah, we have. We're going to use the Y-test testbed, which is an open to public testbed in NYU-Poly. And there we have nodes similar to what Ivan has in WINLAB, WiMAX enabled. And we're going to use them to run this experiment. This experiment uses 3 different applications. The one is WMX stat, which will tell us the link quality, CNR RSSI. This is something that we would like to measure. Okay. Excuse me?
Similar like NetStat, but for wireless connection.
Yes. The other one is iPerf, which will generate some traffic. Everybody is familiar with that. And the kubeshim, which is the basic program running, doing the packet recovery. So we have, and all these measurements will end up at an OML database, which is here on our server. And this OML database will, after the end of the experiment, will send them into iRoads, which with iRoads is a place that we store the experiments, we archive them, and we have a web interface where we can plot them. And when we get to the end of the tutorial, we're going to see what we're going to do. And basically, this is the setup. And next, here we give some information about OML. So we have the code of this program, and we want to put some hooks into the code so that the measurements that we do would be sent to the OML server. So these are the hooks.
Request receive send.
This has to do with which packets the mobile will request.
You want to say request packets, receive packets, and send packets.
Send packets, yeah. This is the whole procedure of packet recovery, right? Where you're missing a packet, you request it. You count if you've received it, if somebody has the packet and send it to you, right? Or if somebody has requested it from you, how many packets you have sent.
And what is the parameters? ID and total of what of packets that will be requested.
Yes.
And ID, it's ID for command, not for packet.
ID, no, ID is for the packet. Which packet?
And total.
No, this is for each packet individually.
Oh, yeah, I see. Total always one. Yeah.
Source string destination. Okay. Who asked and where I'm going to send it. Okay. Next. Here you have this prerequisites to use a WiMAX testbed, how to load an image into a node, how to save it, and basically what I'm going to do is first run it once, and then you can try running it yourself, okay?
While you're running, can you explain again what is IMF model?
OMF what?
IMF command, IMF model.
Okay. The OMF command, oops, sorry. What did I do?
As I understand, OML is database.
Yes,
OML. OMF.
Excuse me?
And OML is database, OML.
OMF is the framework that will
work with the database.
Yeah.
I see.
So, you want me to explain the command?
No, it seems I understand what
Okay.
you're doing.
Okay. So, and we have in the next page we have an application wrapper. This application wrapper, what it does is gets the data from the hooks that we put into the program that we're running, and this wrapper actually sends the data to the OML server. And this is the experiment script. This is what actually we run. And yeah, it's written, basically it's an OMF script which is based on Ruby. What we define here is the set of nodes, which interface they're gonna start. X0 is WiMAX. And W0 is the Wi-Fi. This is for the ad hoc network they're going to create between them. And the WiMAX is to communicate with the base station. And we define which application they're going to start to run. Here we have iPerf and kubectl, and also WiMAX Stat Universal, which is again the WiMAX Stat Universal is the application that will collect the measurements about the link quality. And then here on event, we start the actual experiment. And wherever you see system is the commands that it's like opening a shell on the server and running these commands. So after imaging the nodes, you have to wake them up with this command, or tell -a on. Next one. And after the end of the experiment, once it's done, you can archive them on the iRoads using the iArchive. And you can go and see them being archived in this web page. ytest.poly.edu/iroads/web. And what you're going to see there, if you plot them, it's going to be these beautiful plots showing you what actually happened.
Or request?
No, this is for example for one status link. You'll see which one.
This is 3 nodes, yeah?
3 nodes. Node 2 has this. Go back. You go here. CNR. Yes, you see CNR in DB, and you see the
CNR?
Is the coded the signal that the coded signal that the strength.
Okay.
And this is for kubectl.
And kubectl shows the number of.
You can see the description down.
Oh, okay. Receive.
Okay, and you have an explanation about these plots here. Okay. So to run the experiments, you need to have an SSH client. If you have Linux, you can just open the terminal, or on Windows, you can download PuTTY. Okay, I'm going to start. So let's go from the beginning. And go step by step. So we have those things we explained. First, you need to log into our server, and your username is tutor01 and the address is ytestlab.poly.edu. I'm going to write it for you.
Well, yeah, I mean, so all we get today is like some power over some time or some threshold. Yeah.
GEC17.
Yeah.
16?
Yes. 16. So, what we need to do first, if you log in, we have to load a set of nodes. We have to load an image into a set of nodes. We choose those nodes, node 4, node 6, and node 13. And we do that by loading. Okay, I'm going to do it first. We cannot do it all together. Okay. And I don't know what. So by running this command, by the way, let's change it to GEC17. The nodes will be imaged.
Is it long?
It's going to take a while. Like network booting. So does anybody want me to explain something again while they are being imaged?
You said we were trying to load command.
Yeah.
So we changed the node number?
No, we're going to use those nodes because they have some characteristics like write as RSSI. And so what I'm going to do is first I'm going to give it a run, and then each one of you will go in turns. Yeah.
I have a general question with the lowest scenario. Of course, let's imagine the huge stadium. Everybody has something like iPad, and the stadium entertainment system broadcasts some HD video with slow motion repeats and so on. What's the size of this database of packets? Is potentially.
Yeah, it's potentially going to. No, what we use is here.
So
there's a window.
It seems we save not only payload of packets, we save all the header. So if for example, two clients want to receive one video, but the packets to them will have the different header because always save on the broadcast.
It's in application layer basically. It goes to the application layer, and then from the application layer we send it back.
Oh, I see. Okay.
And you can define here the queue size in the code scheme. How many packets we can?
About what queue we talk?
You said that the queue of the packets. For example, how many packets I'm gonna save to send it afterwards, right? This is an issue.
For me, it means how.
Let's say that you are the lucky one who gets a very good signal. So you have to save several packets and wait till somebody asks you for them, right? You cannot save the whole video, right?
Yep.
So you define that.
And do you think that for when a lot of users are close to each other and everybody could recover their packets or save to our database, maybe it will be more useful to use something like peer-to-peer architecture, or like a peer-to-peer
No,
TV?
we are saving those. No, we're not saving the videos into the database. We're saving just the data to measure how many packets were requested.
Oh, I see.
This is not the scenario of the. I mean, what we're going to do here just show how many packets were received, how many packets were sent, how many packets were requested.
Okay.
So the OML part and the database part is different than it's different basically than what is going to happen actually if it was implemented. So you don't use any. Let's see if as you can see, it's taking some time. The on-off load. 3 nodes were successfully imaged. So now we have 3 computers with an operating system and the programs that we want on them. Move on to the next. Oh, sorry. I went too far. Now we need to bring back the default setting of the base station. And reboot the base station. This error is not very important. It did its job, what we wanted. So now we need to wake the nodes up with OMF-tel-A on. And the topology, of course. All right, great. I'm going to ping them to make sure if they wake up. Four. It's going to take a while. We just gave the order to wake up, just booted them up. So till they wake up. Everything is okay?
My computer is being recalcitrant. I worked on the network for here for the last 2 days, and it cannot get off net to save its life. And I've rebooted it, so.
Okay, so since we're going to go in turns, I'm going to give you my computer next, and we can try. No, so it's still off.
It's still rebooting WiMAX station, yeah?
Excuse me?
It's because it's still rebooting WiMAX station.
No, it's just they are like old computers.
Okay.
Not very old, but yeah. So now we have they're up. So next, what we do is we want to run the experiment, and we do that with this OMF execute, and this is the WiMAX. This is the experiment script. Let me just check if everything is correct there. Yeah, these are the nodes that we want. Before doing that, I'm going to do something that you cannot do. I have to go to inside the WiMAX base station and start, because we said that the scenario is that the WiMAX base station will start sending traffic, right? So somebody with
something like generator. Yeah.
Yes.
So you see how it's giving you the information on the console itself. So you see how it says property.nodes, property.nodes. That's what you want. Everything with what you're trying to see is kind of application. So all of that is when I hit the node, basically picked up all those numbers. The node I'm loading it at, the name of the image, the test that I'm loading it at, and right now what it's doing is it's trying to break up the time.
This is something that somebody with leveraged access should do. And yeah, this is basically I'm doing the work of what a base station inside the stadium would do.
Yes, I understand.
So rerunning the server.
And we send on each IP on this pool, yeah?
Yes. It's basically, oh no, it's a broadcast IP.
Oh, okay. So the IP, all three are at the entrance for this.
Right. I don't remember. No problem, I have saved it. So, Dropbox. I'm sorry.
So for this solution, we actually just created this temporary slowdown. But in general, for the software has a fixed login or this. So if you want to try this out later at your own institution, you can follow the setup. We are in the process of creating the new folders.
So now I'm generating traffic onto the network, and we're going to execute the experiment. On exec, and let's go. So now we're starting the application that we wanted onto the nodes. It's going to take a while. The traffic is being generated.
Yes, and we save all this data about generated traffic in our database, yeah? Not yet now.
Not this once yeah, now it started running, and now we're sending data to the database. But not the packets themselves. Some statistics about them.
Yes,
Okay. This error had to do with TCP. It's going to run. It's basically when we see this error, we understand that it's working.
Yeah, I know.
Hi. GEC17.
When we work with old version, we make some experiments with open flow controller, I suppose. So on Nox, it's always said about when I'm saying TCP session traffic is the 3 hour handle. Okay, that's why it's working.
Okay.
Because here always don't like something like size or something reliable like length. It's not familiar to him. Okay.
It's trying to read, yeah. So what it does is we communicate to the base station using these posts. So this WGET is basically touching the base station.
So now the experiment is done. The next step is to store it into the iRoads web server. Okay. So each experiment is associated with an experiment ID, which you can see the beginning of the experiment.
So the image is loaded on the client. Next, I want to load the image on the server.
Or I'm typing everything. I'm sorry. Yes, here. The experiment ID. It's the third line whenever you just run the experiment. It says experimenter ID, and this is your experiment.
So I got a very informative
I'm
message.
gonna copy it. So if you go to the tutorial page, you will see that with this command iArchive, we can archive this experiment into the iRoad server. And we will do that, but basically we're going to put some metadata and the SQL database of the OML service there. And we do this in order to be able to plot several stuff and see how the performance of our scheme. So
How we could get experiment ID?
I'll just show you. This is experiment ID is one of the first things that would appear on your console once you start running. Oh, sorry. Here, experiment ID.
Oh, wow.
Okay. This is the command that I ran to execute the experiment, and the third line is experiment ID. So, iArchive -e, which means experiment. Cool. So, with iArchive, I will archive this experiment, which, when I say experiment, is the SQL free files and some metadata associated with it. And by -c, I define which collection. Collection is basically a folder. Okay. And this is the name of the folder.
So right here, now the nodes are waiting for us to
Okay.
So if you see right here, when all
Now, if we go to this web page, this is the iRoads web page, and connect to the iRoads. UMass.edu. And your username and password is the same that you use to connect with SSH. Password is GEC17 and GENI. Let's see. All right. So basically what you're going to have is like an operating system. It's a network operating system. So you press on this, and this is the experiment that we ran today. You can see the date. If you double click on the SQL, we have some options. You can just download it and run some SQL queries on it, or you can plot it. First, let's go to the WiMAX status link. And we can, on the x-axis, we can have the OML sequence, and we can see the RSSI, for example, by send the right plot. See? This is the fluctuation of the RSSI throughout the experiments, which will last about 60 seconds. We need to add a back button to this. For now, jump plot again. And let's go back to the tutorial itself and see. So this is what we did. Now, we can go to the table of kubectl requests, how many packets have been requested, and plot them. Again, do them.
Why just linear?
What?
Why it's linear?
Because all the packets that there's an explanation down here. Yeah, we see that under this particular condition, the recovery protocol was successful. All the packets that were lost.
So shows there's some of loaded request packets, but not the request packets plotted at a single period of time.
No, it's not time. It's the almost sequence of it. The almost sequence is at each step what happened.
I understand.
Let's do it again. Total, yes. Got lost for a bit. Grouped by almost sender ID. And we failed.
You get a stubber out and
Yeah.
off his back, and there's some here. Oh, you see that in that part.
Yeah, it didn't. Just one packet was requested in this time. Nothing was.
Packet back and stuff. But he's saying why that
Okay, you can.
We can run it again and
That's
again.
the receive. Not sure.
Yeah, this is the receive.
So the OCOS
Oh, sorry. Plot. Received. One more sequence. And total. Group by sequence. No, group by sender ID. Again, one. So one was requested.
One was
We had
requested,
very
one
good
was
chance.
sent, and one was received.
Yeah, we would like to demonstrate. Send doesn't matter anymore. We know what happened in the network now.
And that means that nobody needs to
One-
recover packets.
Yeah,
Yes.
one node had lost one packet, and it recovered it.
Okay.
Yeah.
And how usually you for demonstration?
What?
How usually you for demonstration make nodes to lost packets to ask
To
for
lose
recovery?
packets, we can do this. We can play with attenuation. For example, we can play with the attenuation. We can bring down the power of the base station.
Ah.
So not all of them have the.
Oh, I see. That's why the red node have a strong signal, yes, and the green node has a very low signal.
Yes.
For losing packets.
So, I hope everything is clear. I'm going to give you, I'm going to come over each one of you and run it together again. Okay, so you start,
Okay.
go to the webpage and try to follow the instructions.
Okay.
Yeah. Okay, so image is done, guys. Okay, let's move on. So at this point, I want my.
Right, that I don't need to load image to the nodes, it's already.
Now you don't need to load, yes.
Turn on so I can actually do something with them. And this is going to basically go and open and bring up the server node, bring up the client node.
This will be easy for me.
Okay, so okay, what was good? So basically we turn on, and at this point I'm going to run the WiMAX implementation RP.
What happened?
Output. 1, 2. No. I want to open the terminal. Yes. Another.
Alt Control T if you want. And I'll open another terminal.
No, not terminal.
This is basically
Tab.
I want to open.
Yeah, go to the GEC17 agenda.
No, I need to, I want to put another box space.
Oh, okay. Tuesday the 1st. First.
Tuesday.
that up, and now it's waiting for the nodes. So the nodes will wait for me to tell them that you, right now it's just waiting for that process to complete. Then we'll keep that stuff out there. It shows you, how many nodes are in your experiments, you go to nodes, workflow checked in, the connections are right, the will know.
Yeah.
And this is
Bring back the base station to default settings. Restart.
No,
It's not working.
kitchen.
All right. No. Next.
Manu, are you okay?
We'll find out. We're running things right now.
I mean, I'm seeing everything okay.
Okay. We'll find out. It was just the data pad and load,
This is not your concern. This is the experiment script itself.
We'll see.
And they are up already. So you just need to run the experiment with this command. Yes.
Okay. We'll find out when we look at ESP2 files.
Okay, go back. Go back. Go to the console. Here you can see your experimentality. Make a copy of it because you're going to need it for the iArchive. Okay.
You see the collection URI, it's basically one of where I extract all the measurements.
Okay.
Basically,
Right.
all the points in the STP file. And right now, as it's collecting that stuff, it's all being piped back into the console machine and it
Okay, we have a slight problem there. One of the nodes is down. Okay, so it's how many nodes are up, sorry, how many nodes are down, and the total nodes you're using in your experiment. So we have 2 nodes up, 1 down yet. I'm guessing that we're going to have to reset that node.
Okay, you can do it only after
Yeah.
experiment.
Yeah. Or to wait till the experiment itself resets it.
And we set it automatically. How long are we waiting for?
We can stop it and do it right now.
Oh, okay.
Control C, yeah. Okay, so how to reset the node? Oh, you haven't tried. Go to the web page, and here we have this command which wakes up the nodes. We can change the on to reset.
On the set. Okay.
Yeah, copy. And make it node 6. All right.
I have the VLC, process all and stuff. Yeah, so there's no magic. I mean, the whole thing looks
Let me check the state of the nodes. By the way, this is our testbed website.
This step that I'm doing manually is just, I could have very easily automated this.
Try to ping it and see if it's up.
The data, I don't know what the database, the data archival service.
Okay, yes. And try to run the experiment again. All right, great. Okay, they're both, all three loaded, you can see.
All the database files, the files, the actual result, everything that you saw, you're reading the background, it basically captures all the state in an XML file, in a log file, so we can actually see where the error is, and then we actually have this SDK file. Okay, now we're going to talk about it.
I got there and the analytics might be the analytics.
Was it okay?
Yeah, we find out if we got any data.
Like it's environment variables, chunk black and sort of had gotten some bits with and it was corrupted, missing a bunch of stuff. You know, barrel goes out.
So you're using
I don't even know, just maybe having it on like a bunch of bits.
It's going to wait for 10 seconds.
Not environmental control at all, so I don't even know. I'm going to wait on the index right now.
All right, I'm going to archive it.
So we spent some time comparing it to working
R.
and view slash, and I got it.
AR, yes.
Relocated the environment variables, all these heavy scripts and stuff that are like
So these patterns are doing
Yes.
and despite all of that, it's still not good to find
Okay.
Yeah, so it's all RPCs, tools,
Whitest lab.
oh, it was really like, I downloaded
.poly .edu / iRods. iRods DS /web. Great. Now, host IP, you're going to find them in the previous page. See them? Host.
oh, it just runs like full on Linux instance on they give you a shell.
No, not your username. GENIConference is the zone. And your username is tutor01, of course. And the password, yes, GEC17. So, coop. Here. Yes, this was the previous one that I ran, and this is yours. You can plot them, and if you see the same things, you can change the power of the base station as shown in the next page. So I'm coming to you now. Hi. So we're gonna do it here on my computer since your computer is not working.
I got to read the web page.
Okay, that's good.
Captive portal won't come up. It comes up on here and it doesn't come up on
Yeah,
there.
maybe it's better to have this open with the web page.
Okay.
So you don't need to change tabs. So
Was, and again, I'm not going to be
Go back.
the dash type thing, but I'm trying to guide you on, how the workflow was and get you set up so you can actually.
so we don't, let's go back there and here. So first we need to bring back the base station into the basic modes, in the default modes. And you do this by running this command. You can write it on my computer.
Okay.
Pretty much,
Opa.
it's all great.
So the default and the restart?
Yes.
Got the data, over time, but then.
It's big O, capital O.
That's what I was looking at. Is it capital O or is it a?
And it's Q, not G.
Okay.
Space, and the rest is easy.
Outdoor, how many nodes do we have? So 3 groups is what, yeah, so instead of like, we little more code, we give you, so you,
Slash default.
The grid is not available.
no, I know that, just outdoor, right?
No, but I mean, you can use.
No space, yes, great. Good.
Yeah. So we just make,
Okay, and now restart the base station.
That probably takes a little time.
Yeah. Okay, that's okay. This error is not important. Great. So now this is the wrapper. I explained it before. You read it on the web page too. This is the experiment that we're going to run.
Right.
Explain this also.
So now we run it?
No, yes. You run it with this command, omf exec.
Do you need to?
No,
No,
they're up.
because you already did that part.
Yeah, yeah. They're up already. So omf exec. Yeah. Before doing that, let me generate the traffic from on the base station. This is your experiment ID. You're going to need it to archive it, as you can see here. This is the experiment ID.
This one here?
No, the one that's experiment.
Oh, okay, there we go.
Yeah, so let me. I'll just copy it.
That's what you're trying to
Control Shift Q.
Control Shift Q.
And now
Q or C?
CC. What you did now was the stopping the experiment. Anyway, run
Start it again and get it to.
Let me stop the generation because it's tiny.
Sorry.
No problem.
I finally got used to Windows being Control C, but I didn't catch you were in the Unix one.
Yeah. Okay. Let me just run it a bit more time. Okay. Not that much. Okay. And then run it again. Just up. And go.
And this time, I'm not going to stop on accident.
Yeah.
Control Shift.
Yes. The nodes are up, you can see. And the experiment will begin now.
Are you getting the same thing? Oh, so gone. Where is it? I think did our reservation expire? Because I was able to do it, but I wanted them to do it. Yeah. Sorry.
So these errors are from the TCP port. It's actually saying us that it's working.
Can you check? Because I
For some reason we have this issue with TCP traffic.
You can?
No, everybody.
So I'm going to need
You already?
No, I mean, but I can't open a new portal.
No, two is star user.
Somebody sent a print message to the error handler instead of. Yeah. It's like the bug code.
No, this error occurs every time that there is a TCP traffic.
So I think he tried too many times, so.
So you're not supposed to go, oh, shit.
Yeah. Okay, so.
Give me a second.
He entered the wrong password too many times, basically denied access to it.
Okay?
And so now we need to put it
Archive
in the
this.
archive.
Yes. Dash E.
Shift Control V.
Yeah, Shift Control V, yes. Great. Dash C. Cool. So what this command does is archives it on the iRoad server. With this, you define that it's an experiment,
Okay.
which means that you're going to have the SQL database and the metadata, some XML metadata. And the collection is actually a folder. You define which folder to put it. Now press enter.
Oh, sorry, it's outdoors. I stopped the grid. Sorry, my bad.
And now you go to the website. No, not. Oh, you can do it from there.
Oh, you've got it already. Probably logged in here. Just Chrome?
Yes. Virus. Just close this. Browse up. Coop.
Because that's where we told it to put it.
Yes. And always the first one, the last one is first. Yeah. If you double click on it, you'll be able to plot. And you can select a table. For example, we can select the for first. Let's start WiMAX status. On x-axis, you will do the normal sequence. Here. And on a y-axis, you will choose whatever you want, a CINR or RSSI. Let's go for RSSI. And group by sender ID, which means which node sent that particular info. Plot. And you see this is the fluctuation, how it's working.
Right, and so those were the 3 nodes,
Yes.
and that was how they were doing.
Yeah.
Okay.
Where's 2, 3, and 4? Used 4, 6, and 13.
So close this and
Close this, and you can plot something else. Let's plot, for example, from table packets received from Kupshi. Again, sequence. Now total, how many packets in total, and group again by sender ID. Plot. Oh, here you have better.
but we only got one sender?
Yes, one of them has one receiver.
Okay.
So one of them had bad condition and needed packets.
Okay.
The other 2 were doing fine, and you can see the.
That would be the one with the real low RSSI needed help, and the other
Yeah.
2 were doing okay?
And you can see the explanation of the plot. Basically, we're lucky we have the same exact plot. You can see that under this particular condition. All right. So if you also have the power to change the attenuation, the
Right.
power of the base station to make it more unbalanced towards the nodes. So one have really, really good signal and the other have very bad signal. So to
And then you'd have probably 2 of those lines.
yeah, or maybe just one, but more packets would be requested.
Okay.
Yeah. Okay.
Thank you.
Welcome.
Appreciate the computer.
Yeah, no problem.
See if I can sort out.
Yes. Are you still interested, or did you lose you? Sorry.
I SSH into the WiMAX server.
Yes.
Now I can run this one out.
I have already ran it before, because this basically puts an operating system with the programs that we need on the nodes that we're going to use.
Okay.
It's like network booting. So they're already booted. What you're going to have to do is to bring the WiMAX base station into default settings by copy and pasting this through there. Yes. If you're interested, you can try other tutorials as well. Stream loading or Dash.
Okay, I'm just going to get this fixed so that I can actually do that. I'll be back.
Okay. Okay. Yes. Enter. No. Again. Oh, okay. And you can restart the base station. Yes. Okay. This error is something that is usual. It's not. No. Now, if you go next. So as I told you before, this wrapper is actually the script that will send the measurements, the measurement points that we're interested in to the OML server. And the OML server is basically a database, like any other database with tables and etc. So next. These are all on your home folder on Tutor 01. And this is the experiment itself. Here you define some kind of properties. So for example here, the syntax is, if you want to use our nodes, is omf ytest.node. So we made it like a type def prefix. And this is the number of the nodes. Here we define the duration of the experiments. Here we define the URL of, we can change the basic settings of our base station using an HTML-based interface with the URL. So by running this and then setting the profile, we can change the modulation and coding scheme. So, and we tell him to tell the nodes to queue till 50 packets.
Okay.
So we do that. We define a period where they save packets. So if they receive a request, they can send it. We don't save all the packets, because it's like a streaming. It doesn't. If you receive a packet like after 1 hour, it doesn't matter anymore.
Right.
So here we define the groups. We call them receivers. We turn on their WiMAX WiMAX interfaces. With this command, they actually connect to the WiMAX base station. Here we give them an IP, and we define the netmax. Same thing for the Wi-Fi. So the WiMAX is the one that the WiMAX interface is the one through which they receive the traffic, right? And the Wi-Fi, they're going to use the Wi-Fi to form an ad hoc network to help each other to recover whatever packets are missing, right? Here we give to the groups the applications to run. This WiMAX Stat Universal is an application that will measure the link status, RSSI, CNR, and frequency. And then we have iPerf and Kubeshim. This is the basic recovery. This is the basic program that we're interested in, the Kubeshim, which packets should be recovered. If you go down, okay. So this is the definition of what we want to do. And this is where we say what will happen when we start running the experiments. So by this command system, we essentially give a bash command to the base station. So I showed you before that we defined a URL for the modulation and coding, right?
Oh, the MCS URL.
Yes, yes.
Okay.
So it ends at profile, and if we go down, we just add 13 here. 13 is the basic profile, which is like QPSK 1/2.
Okay.
And here we change it to the highest, it's 16 QAM. Profile 21 becomes 16 QAM.
Okay.
And we define several stuff from OML that we need here, basically. It's essential to the experiment. And at this point, we tell them to start the applications. These are the applications we define: Kubeshim, iPerf, and the other one, WiMAX status. And then whenever everything is done, okay. So this is basically the experiment that we're going to run. If you press next, so if you have started. If you had loaded the images, you would use that to wake the nodes up. But since the nodes are already up, you just have to run the execution command. Copy, and before you do that, I need to. Oh, what happened? Excuse me? Yes, because I need to generate the traffic on the WiMAX base station. Okay. Yes. So Kubeshim is running, and I'm running it for. So you start. Okay. And now. So this is your experiment ID. You're going to need it for archiving your experiments on iRoads. This ID. Don't worry, you're going to see it at the end again.
So you guys are using that to give me lab wiki interface. You guys are running it more, I guess.
Yeah, this is normal. Yeah, this is some issue we have with TCP ports. That's going to take some time. Okay. Now the experiment is about to exit. Great. So, this is your experiment ID from tutor. Please copy and paste it. Copy it, basically. Yes. Copy and and you run iarchive -e. No. Instead of experiment ID, you just put the one that. Paste. Yes. C correction. Cool. Great. Enter. So what we did, we are archiving, saving this experiment, which is the SQL database that we have in OML server, plus some metadata, XML metadata, which will help us to plot it. Now it's been archived. If you go to this web page, yes, get this one, and the host IP, port, and zone are given into the previous page from which you came. Here. Oh no, this one. Oh, these are host and yes. 47, yes. No. This was the zone. Your username password was tutor101. 01 and password is GEC17. GENI. Yes. Okay. Yeah, I have this problem again.
Is this the survey? Yeah, I have the URL.
Oh, okay, you don't want it.
No one said.
Let me see if iRoads is down.
Oh, okay.
No, it's not. I don't know, I'm just GEC16. Failed connection to email. We're using the right port number.
Check out the NSVD. There might be an extra space at the end.
Oh,
I saw.
okay, great. Should trim it.
Yeah, and that would result in.
Yeah. Here your experiment.
Okay.
You can double click on it.
Any of it? Or?
This is basically what you did. This is what this gentleman did.
Top three.
Yeah. Oh no, the SQ3. And you can choose plot. And you can select table. So what we did, we were creating different tables for this database. One of the tables is, for example, WiMAX status link. You can see if you press it, on the x-axis put the almost sequence, sec, and the on y-axis put the, for example, RSSI if you're interested, or the CINR, and group them by the almost sender ID, which means which node sent which data.
CNI signal noise ratio?
No, this is the RSSI. This, the CINR is the coded. Yes. So you can see the fluctuation of the CINR. As you can see, one node is very, very stable and high. The other one is low. And one has a lot of fluctuations. It varies a lot. So close it. Now we can go and see plot again. We can go and see another table, for example, the received packet. Which packet you received from the Kupchin. Again, sequence, y-axis, total packets, and group by sender ID, plot, and this is it. And if you go back to the web page, we're lucky today. Everything is according to...
This web page?
Yes, go down. Next. These are the options of plotting that we give you.
Okay.
Received, and as you can see,
We have a similar chart as well.
yeah, and you have an explanation down there. If you go next, you can see you have. Oh, sorry. You have also the option to change the transmitted power of the base station, so you can create a condition of more unfairness towards the nodes. And you can try it by yourself later. Well, I'm going to this gentleman. Sorry for keeping you waiting. Yes. Okay.
So what I'm trying to do is sort of read things, and I'll do it when I get around.
Oh, okay. But you need to have a reservation on our testbed to do that. So do you have an account on our testbed?
I don't.
So what you can do is basically go here, and you can just press register, and it's like registering. It's ytestlab.poly.edu. So register. Yes. And you can just send, and we're going to send you back the account information.
Thank you very much.
Welcome. No problem. Do you want to run the tutorial? Hello. It's actually useful. Excuse me, sir. Which tutorial are you doing? Or are you interested? Stream loading. Okay. Okay. With you one. Okay. Kind of stream loading. So as I told you before, you can run the experiment again with different, TX power. So since you two are the only one who ran it, you can just coordinate to not run it. And you can tell me to generate the traffic if you want, you're interested. I'm going to be here. Just let me know when you're ready to run. So what you need to do is, before running the experiment, run this command. Two commands, okay? Whenever you're ready, just let me know. still need me to wear that?
What's that?
Do you still need me to wear that?
I think we're about done. I've just been kind of rolling on you as you were teaching.
Okay.
So,
Yeah.
I didn't know this is what you guys are going to do.
All right.
But, okay. Just wrap it up here soon.
Okay. Oh, I'm sorry. I'm sorry.
Go to WiMAX tutor that.
Everything's okay?
Yeah.
Good. WinLab, you have to go to 3. Again, ours is. So these are the 2 test beds. This is WinLab, this is us. Μπορούμε να αλλάξουν και το power. Ορίστε. Όχι, δεν χρειάζεται. Εκείνοι είναι πάρα πολύ και δεν έχουν καταφέρει καν να τελειώσουν το tutorial, οπότε δεν ξέρω. Κάναμε μαζί με φέλη.